Hello and welcome to this episode of Gowing Life's Longevity Weekly with me, Chris Kerwin. This is where I bring you the news and updates from the world of longevity, health and wellness. So today we're going to be talking about the interventions testing program in the United States. We've also got a short excerpt from our talk with Dr. Greg Fahy. And we're also going to be talking about whether hibernation is an effective strategy for human longevity. So without further ado, let's get into it. So first of all, the interventions testing program. What is it? Well, it's a program set up in the United States to rigorously test drugs that are capable of extending mice lifespan. It is widely considered to be the gold standard for this due to three crucial factors. They use a large number of mice for each study to ensure sufficient statistical power. Secondly, the investigations are run in parallel at 3 different sites across the country. This ensures the results are reproducible in different labs. The mice cohorts are genetically heterogeneous, sharing only 50% of their DNA with each other. This means that they're not all very closely related. Therefore, it's much more representative of a normal human population. So importantly, the ITP focuses on testing compounds that have already been approved in humans for the treatment of other diseases, and therefore have a robust safety profile, which lowers the barrier for bringing these compounds into human clinical trials. This program has played quite an important role in progressing the understanding of these longevity drugs, and is currently in the process of looking at a number of different compounds, which you can see up on your screen right now. Now, secondly, I want to bring your attention to a talk that we held with Dr. Greg Fahy. Now, Greg is a world-renowned cryobiologist, and he's also the Chief Scientific Officer and co-founder of Intervene Immune, a company in the United States who are looking at thymus regeneration and age-related immune function decline. So here is a short clip from our talk. So on the topic of thymus regeneration, in September 2019 you published a paper on a study in which a cocktail of 3 drugs, DHEA, I think it's metformin and then GH, correct me if I'm wrong, it seemed to reverse the biological age of humans by about 2 years. Could you give us a bit more details of this study?
Right. So the drug cocktail is a combination of growth hormone, DHEA, and metformin. And the growth hormone is what regenerates the thymus. So we've known since 1986 that if you continuously expose an old rat to growth hormone, the incredibly deteriorated thymus, which looks nothing like a normal thymus, both histologically and physically, the thymus actually shrinks down to a size that was so small that they couldn't even weigh it in the study. It looks like a glob of fat, but you can still bring that thymus back by giving the animals cells that secrete growth hormone constitutively. And they found that when they did that, not only did the thymus come back to its normal morphology, but T cell ability to respond to foreign antigens was restored back to the levels seen for a 3-month-old rat. So that caught my attention. Everybody else ignored it. And so the TRIM trial was designed to see if we could do something like that in humans.
So as you can hear, it was a really fascinating chat with Greg. So please go and check it out. It's on our YouTube channel and on our website. And yeah, just another massive thank you to Greg for coming and giving us some of his time and insight. So thanks again. So our third and final topic for today is on a piece that was written by my colleague Alex about hibernation and longevity. So now obviously humans don't hibernate, but could they? Certain animals enter a state of hibernation to help them survive cold, stressful conditions over the winter. Hibernation is often described as a form of sleep, though this isn't always completely accurate. It's more akin to a complete slowing down of their metabolism to conserve energy. We may be able to learn some important lessons from the metabolic adaptations that occur within these species. When humans are bedridden for an extended period, we suffer significant health deterioration, such as the weakening of our muscles, including cardiac muscle, i.e. the heart. So hibernating animals, on the other hand, have evolved ways of conserving most of their muscle mass during periods of rest, and are able to survive at extremes of temperature that would otherwise be fatal. Now, could we perhaps induce some of these metabolic changes in humans in order to slow down aspects of the aging process, such as muscle and bone deterioration? Could we even make humans fully hibernate in order to allow for things like long-distance space travel? The idea might not be quite as crazy as it actually sounds. The scientific consensus is that the ability to hibernate arose in a mammalian ancestor around 65 million years ago, and that this ancestor is common to most mammals today. That means that all of the genes necessary for hibernation are likely to be present within the human genome. However, they have just been turned off. We know of one primate, the lemur, that hibernates for long periods. So it's not much of a stretch to imagine that by understanding which genes are activated during the hibernation process, we might be able to target those same genes in humans for medical purposes, or to one day regain this ancient ability that has been lost. And that is it for another episode of Longevity Weekly. So I hope you've enjoyed it. Please go and check out the website for more interesting news on the world of longevity and health. We've got an article up there at the moment about how rapamycin is being used in a human clinical trial to treat cognitive impairment and Alzheimer's. We've got another article about mitochondrial health being boosted by metformin, and a load more longevity bikes for you to have a look at. So go and check it out, and thank you again, and see you next week. Goodbye.